Good morning. So we are going to start chapter 20. In this chapter, we're really just adding some extra details in to what we have already learned about hypothesis tests and confidence intervals in chapters 18 and 19. So a lot of this stuff's going to sound familiar. We're just taking a deeper look into parts of it and giving some names to some things that we've already talked about. All right, so remember that when you have a p-value, if it's low, we reject the null hypothesis. Right, so if it's a small number, we're rejecting the null hypothesis. If it's high, then we fail to reject the null hypothesis. And to help you remember that, you can remember the phrase, when the p is low, reject the hoe. But what does it mean for the p-value to be low or high, right? You all like to have a set number to be able to compare to because you don't like when I make a guess. So we're going to set an arbitrary threshold for what p-value you would consider to be rare. When a p-value falls below that threshold, we say that the results are statistically significant. You've heard that phrase before, right? And you were always looking for a small probability of that happening. But now we're going to actually call it something and have a number to compare to. And that is called the alpha level, okay? The notation for that is the Greek letter alpha. It's lowercase alpha. It looks like a little fish. Okay. Also, it can be called the significance level because it's the level at which you can find statistically significant results. Okay, so this is, if you've ever done an honor science project, if your science teacher said you're going to run your t-test, and at the end, if the number you get is below 0.01, then you can draw a conclusion, right? So that's kind of what we're talking about with the alpha level. The most common alpha levels that you'll see are 0.05, 0.10, and 0.01. But that doesn't mean you can't have other numbers. Those are just the ones that are chosen most often, and it kind of depends on the context which one you would choose. Okay? When we reject the null hypothesis, we can say that the test is significant at whatever that alpha level is. Significant. So if I reject the null hypothesis and my alpha is 0.05, I can say that the results are, or the test is significant at the 5% level. Okay? You can also, which we kind of did this in chapter 18, you can approximate doing a hypothesis test by using a confidence interval, but you need to know how they go hand in hand, and that's something we're going to talk about in a second. Okay, so if I choose an alpha level of 0.05, right, that would mean that if I run my hypothesis test, I get to the end, I find the p-value. If it's less than 0.05, I would reject the null hypothesis. If it's greater than 0.05, I would fail to reject the null hypothesis. Okay, but I want to know what confidence interval level would be associated with an alpha of 0.05. Okay, so let's do an example here for a second. Let's say my alternative hypothesis is that p is less than some p naught. Okay. If my alpha is 0.05, then that means if my p hat ends up being anywhere here or below, I would reject, right? This is my alpha is 0.05. We reject if p hat falls here, right? If p hat is 0.04, it's going to be to the left of that line, and then we would reject the null hypothesis, okay? So what do we know about the location of a confidence interval on the normal model? It's always in the center, right? Always in the center. So I'm going to go symmetrically that way. This is my confidence interval. It's going to be somewhere in the middle. Okay. So what percent is in the middle if I have 0.05 on the left side? Well, if I have 0.05 on the left, I also have 0.05 on the right. So to get this whole thing to add up to 100%, I would need 90% confidence. So if my alpha is 0.05 and I have a one-tailed test, meaning I used less than or I used greater than in my alternative hypothesis, then I would use that with a 90% confidence interval. Okay. And so the rule for that, if it's one-tailed, our confidence level, C, is equal to 1 minus 2 times alpha. And you can memorize this rule. Personally, I always just draw a picture and I look at it just like we just did. But if you like to memorize stuff and you think you can actually really remember it, it's not on the reference sheet, feel free to do that way, okay? Next, if I give you a confidence interval level and want to find the corresponding alpha, well, we know that our confidence interval is going to be in the middle. All right, this is my confidence interval. We're saying it's 95%. If it's a one-tailed, I only care about one side, right? But if 95% is in the middle, that means I have 5% left over. So I got 2.5% on this side, 2.5% on this side. But because this is a one-tailed test, my alpha is only the one side. So alpha would be 0.025. Okay? So that's how it works for one-tailed tests. Again, when your alternative is a less than or greater than, you would use this method to go from alpha to the confidence level or the confidence level to alpha. Okay? If you have a two-tailed test, it works a little differently, right? Your alternative hypothesis would look like P is not equal to P naught. And if it's two-tailed, that means that your alpha of 0.05 is included in both tails. So that means these both add up to 0.05. Because if my p hat is in either of these sections, I will reject the null hypothesis. So if 0.05 is all that stuff I just shaded in, what's left in the middle? 95% for my confidence interval level. Right? When we did the one-tailed test, the alpha of 0.05 corresponded to 90% confidence. Here with a two-tailed test, it corresponds to 95%. So you can find your confidence level by doing 1 minus alpha if it's a two-tailed test. And then if I give you the confidence interval level, you can tell me what the alpha is. We know that the 90% here is going to be centered in the middle. Ignore my bad picture. This is my 90%. What's left over? 10%. So that's 0.05 over here, 0.05 over here. But because this is a two-tailed test, I'm including both tails. So I need to add up both of these things rather than just taking one side because it's two-tailed. So my alpha is 0.1. All right. If you need a minute to go through that again, feel free. I do have some examples on the next page that you're going to try for yourself. So I would love for you to pause the video now and try a couple of these and then come back and see what the answers are. Let me just go through with you. Let me put some normal models in there. Because like I said, I don't use the rules. I like to draw a picture every time. Okay, so two-tailed test. Alpha is 0.02. That means that if it's two-tailed, I'm counting both sides as my 0.02, which means I've got 0.01 over here and 0.01 over here. So what's the confidence level that's left in the middle? 98%. Okay, check out the next one. One-tailed test with an alpha of 0.02. So this time, if my test is one-tailed, here's my 0.02 over there. I don't care about the other side, but I know that my confidence interval has to be centered. So there is a 0.02 over there that I don't really need, but it's there, which means when I'm centered, the confidence interval level is actually 96%. And then for the last one, one-tailed test, alpha is 0.1. Okay, we know it's going to be centered. My one tail is just one side, so just this side is 0.1. I also have 0.1 over here, so what's left in the middle? 80%. All right, the next few problems are using the confidence level to get to the alpha level. So if you need to pause and try those, you can do that now, and then I'll go through them for you. Okay, so two-tailed test with 98% confidence. We know that our 98% is going to be centered in the middle. So what's left over? Well, I care about both tails. So alpha is going to be 0.02. And notice how the confidence interval level is a percent, but alpha we leave as a decimal. That's important, okay? Next, we have 85% confidence in the middle. This time we're only looking at one tail though. So if I have 85% in the middle, that means I got 15% left to be here and here, which means that my alpha level is half of that 15%, so 0.075. Okay, and last but not least, we got a 99% confidence interval with a one-tailed test